So let's go to the next question. This one comes from Pumla Cheki. It's also about finding the derivative. So I'm going to be quick on this one because you guys have seen already how the power rule works and how the first principle concept works. So I'm just going to do this one because it's very important. It actually caught my attention. Right. So this question reads as follows. It says to us here, write all answers with positive exponents. Right. They say find, right? Determine. Okay. And they're not saying anything. They just wrote D here with a small x, and then inside the brackets, they have 1 plus the square root of x with a square, right? Now, what exactly is happening here? This actually speaks to us about notation. If you understand what the whole thing is asking here, that capital letter D there is asking you to find what we call the derivative. They're asking you to find the derivative, right? They're asking you to find the derivative. Okay, cool, right. Now, what are other notations that we have? Well, we've got different notations that we use for denoting derivatives. For example, sometimes we might have, let me write it like this, we might have a function, and we also want you to know the derivative, how the derivative is going to look. This is just specifically to help you with notation. Very, very important, because in one exam, I remember when we were marking, the examiner said we need to penalize you for not following the correct notation, right? So it's very important for us to also highlight that I can't be giving you d of x and then you suddenly appear with y. Why are you doing that? You can't change d of x to f of x. Work with what we give you, right? So if I give you a function as f of x is equals to blah, 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 when you are deriving it, you're just going to put a prime. We're going to say f prime of x equals to whatever the derivative you're going to be working with. If I give you my question or my function as y equals to blah, 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 you've got two options. You can either write y prime equals to whatever, or if you don't do that, you can write dy over dx equals to whatever the case might be, right? So very important for you to keep that in mind. Those are the two things that you might need to keep in mind when you're working with this. And if I just write my capital letter D with an x and I put my function or my expression inside those brackets, you're just going to go straight to the answer and give me whatever the solution that you're working with. So be careful. All these are just asking you to find the derivative. These are different notations. You can have another one that is d of dx, and then we've got a function inside the brackets like that. It's the same thing. We're asking you to find the derivative, right? Now, remember what I said? In order to find the derivative, the first thing you need to do is make sure everything is in the form coefficient-based exponent. Now, this question stands out for me because you'll notice that we can't start deriving because it's not ready. So I'm going to keep my d of x, right, and say someone is going to make a mistake and say this is like as good as squaring 1 and squaring that square root x. Don't do that. That square means you've got 1 plus square root x and another 1 plus square root x. There's two of them in total, right? And then now I'm going to apply, and notice my d of x keeps following me because I'm actually still reminding myself that I need to derive and I haven't done the derivative. So this guy multiplied by 1, we're just simply going to end up with 1. And then that guy multiplied by the square root of x is going to be the square root of x. The square root of x times 1 is going to be another square root of x. So I've got two of them in total. 2 square root of x, and the square root of x times the square root of x. From our laws of exponent, we know that is going to just amount to x because it is the square root of x squared. It's just going to become a value of x, right? Someone is asking, but how? How do you actually get to that? Well, x, the square root of x is as good as x to the power 1 over 2. When you change it to surd form, from surd form to exponential form. So when you're asking me to do square root of x times square root of x, I'm just doing x to the power half multiplied by x to the power half. And when you multiply same basis, laws of exponents, when you multiply same basis, you add the exponent. So half plus half is going to amount to 1. That is why my last term is just x raised to the power of 1. Please be careful of these laws of exponents. You can never overemphasize this. Right. Now I'm ready to derive. Because now I'm deriving. No, I'm not. The second term is not right. This 2 square root of x is not right. So I'm going to change it to exponential form. So which means I'm going to still retain my d of x. Even though 1 is ready for differentiation and x is ready, I'm not deriving them. I'm just parking them as I fix the second term and changing it to x to the power of 1 over 2. Where's the 2 coming from? There's an invisible 2 here, even if it's not written. All square roots have a 2, even though they are not written there. And inside of that square root sign, we've got a half x to the power 1 there. right? So that's where the 1 over 2 comes from. X is x to the power of 1. The square root is just with the 2 outside, so that's amounting to x to the power 1 over 2. And then the last part here, we still have got that plus x. Okay, cool. So now the derivative of 1 is a constant. We said it's going to be 0, so I'm going to ignore this. It just becomes 0. The derivative of the second term, which is 2x to the half, we said it's exponent times coefficient. So half of 2 is going to give you an answer of 1. X to the power of half minus 1. Half minus 1 is going to be minus a half. Now, on the second one, remember, there's a ninja 1 here hiding, and there's another ninja 1 here hiding that we never write to confuse people who are not mathematicians. So 1 times 1 is going to give you a 1, right? So I'm going to have plus 1 there, x to the power of 1 minus 1. This here, beautiful people, is going to be x to the power of 1 minus 1, which is going to be x to the power of 0. And we know that x to the power of 0, provided that x is not 0, will just become a 1. So in completion, this is as good as just 1 over x to the power of 1 over 2 plus 1. And this is the solution to this derivative that you guys wanted us to work on. Beautiful, beautiful question indeed. I hope, Pumla, you can see what you needed to do here, right? Not complicated at all. It's very basic and straight to the point. The only thing you need to understand is the laws of exponent, how to work out with multiplying same bases, how to change from cert to exponential form, how to divide same bases. If those are fine, then you won't have problems when you're working with applying your knowledge in differential calculus. Right, so let's move on to the second part of Pumla's question. Beautiful part here. It says to us here, we are given a function f of x, right? It says here, if you are given, right, given the legend, f of x is equal to 2x to the power of 3 plus 3x to the power of 2 plus x plus 5, right? We now want you to do something very exciting. We want you to find, they say, find the derivative of f. Okay, notation, notation, notation. Find the derivative, find the derivative. So when I'm finding the derivative, I'm just deriving, right? We need to find the derivative. So I'm going to say, okay, they didn't say I need to use first principles or anything like that. So I'm going to go straight and derive using the power rule. I'm going to say the derivative, and you will notice that I'm now deriving because I'm putting a prime, is equal to exponent times coefficient gives you 6, x to the power exponent minus 1, which gives you 2, 2 times 3 gives you another 6, x to the power 2 minus 1, which is 1. On x, I've got 1 times 1, which is going to give me 1, x to the power of 0, and the derivative of your 5 is just going to become 0, so we're not even writing that. So this is a 1-mark question. It's asking us to find the derivative. So that is the derivative of the graph of f of x. Now, I'm interested in the second part. The second part is what actually interests me. It goes on and says, find, right, the gradient, okay? Find the gradient of f at x is equal to 3. All right. Now, this here, beautiful people, is what grade 11s would actually freak out if they found, right? It's what differentiates grade 11s from grade 12s. We all know we've been doing it from grade 9, how to find the gradient between 2 points. We call it average gradient, right? y2 minus y1 over x2 minus x1. Change in y over change in x. Rise over run, whatever you were calling it, right? We all know this. We know for a fact that you can be able to find the derivative, not the derivative, but the gradient. Gradient is the key word here. Gradient is not a new concept. We know it from analytical geometry. In order to find the gradient, we need 2 points so that we can do y2 minus y1 over x2 minus x1. But this examiner is asking us to find the gradient at 1 point. And that is where, beautiful people, calculus takes over. That's where calculus takes over, because in order for you to find the gradient at a point, you're just going to find the derivative at that point, right? In fact, every time when you're finding dy over dx, or when you're finding the derivative, right? Or when you're finding f prime, you're actually calculating the formula for the gradient at any given x value. The derivative could be imagined, it's not necessarily like that, but you can imagine it as a fancy word for gradient at a point. Please keep that in mind. So let's sum up this for you nicely. There are 2 types of gradient that you as a grade 12 need to know, right? The first one is what I call average gradient, right? There's average gradient. Remember, we are answering your questions at the same time. We are trying to educate because we understand that you don't have the privilege of meeting somebody face to face who is going to explain what is going on here. There's average gradient and there's also instantaneous, right? Instantaneous right? Gradient. Instantaneous gradient is gradient at one point, which will freak out grade 11s and grade 10s because they'll say, but how do you find the gradient at one point? Because we are expecting to have y2 minus y1 over x2 minus x1, right? So for you to find average gradient, it works with 2 points. You need 2 points, right? Point, and you need another point with x1, y1, and x2 as well as y2. In order to work that out, we say m average is y2 minus y1 over x2 minus x1. We've been doing this since forever, right? Now, the one of instantaneous gradient is what actually is unique to grade 12s. This is what is unique to grade 12s. This is basically where we just need 1 point, not 2 points. You actually only need x, not even the whole point. You just need an x coordinate and that's enough. Why? Because the gradient, right, the instantaneous gradient will be denoted by the derivative. Your gradient, right, will be the derivative, right? The derivative of the function at that particular x value, right? Now, this question is a nice question because we have already found what the derivative is. If you remember from the first part of this question, we were told that f of x was something which we then manipulated to find f prime as 6x squared plus 6x plus 1. 6x squared plus 6x, right, plus 1. So I'm going to take that. I'm going to say, okay, we are looking for the gradient at one point. We're actually looking for instantaneous gradient, right? So examiner, the gradient that you're looking for is equal to f prime of x at the point where x is actually equal to 3, right? So what is going on here? No complications. Let's just go back and write it. Our f prime of x came out as 6x squared plus 6x plus 1. That's what we got when we were finding the derivative using the power rule. 6x squared plus 6x plus 1, right? Now, once I've got this, I'm looking for the derivative when x is equal to 3, which means we are looking for the gradient when x is equal to 3. So wherever I see x, I'm going to replace that with 3 squared plus 6 into 3 plus 1, and then the rest is just calculator work, which you can obviously try to figure out by just saying 6 into 3 with a square plus 6 into 3, and then we're just going to obviously add a 1 at the end, and then this is going to amount to 73. So the gradient of this function when x is equal to 3 was just going to give you a value of 73. A very beautiful question indeed. I hope you understand what the story is. I just dragged this because I wanted to make a point of why are we really worrying ourselves with calculus. It helps in a lot of things, and one of them is on finding gradient at a point. Something that sounds insane. It sounds crazy. How can you find a gradient at one point, right? You can using differential calculus because of the concept of limits, and we just saw an example on that, right? So I'm going to move on to the next question that was sent by you guys, and now this one is a graph question. I have done all the questions that involve differentiation. If you still have more of them and you still want more clarity and more explanation, please keep them coming. We're waiting for them, right? So let's go to the next question here. The next question is a question that comes from Taeto Peta. So Taeto is a graph question that Taeto wanted us to look at. So it reads as follows. It says we are given the legend, right? We are given a graph of f of x, which is given by f of x equals x to the power of 3, right? Minus 4, x to the power of 2 minus 11x plus 30. So this is the function that we're given, which happens to be a function of x. Now, just by looking at it, you can see that this is a cubic function because the highest exponent of x is a 3. Now, when you're dealing with cubic graphs, we are expecting, not all the time, we are expecting the graph to cut the x-axis 3 times. It's the third order question, right? We're expecting it to cut the x-axis 3 times. That's actually what you can always use to decide what is going on. So this 3 tells me somehow that I'm going to have 3 factors in this particular graph, and this graph is likely, not certainly going to happen, likely to cut at most the x-axis 3 times. It can cut it twice or even once. There's nothing wrong with it, right? But that's essentially what is going on here. So the first question says use, right? Now this is number 1. They say use the fact that f of 2 is equal to 0, right? To write down, okay, to write down a factor. Very beautiful stuff. Okay, this connects us with the factor remainder theorem that we spoke about a while back. No complications there. Very beautiful stuff. The second question is asking you to find or calculate coordinates, very important, of the x-intercepts. Okay, beautiful stuff. And the third concept here is asking us to find stationary points of this graph. Okay, find stationary points, no complications there. And they're asking us to sketch the graph. They want us to sketch the graph. And lastly, they're asking a beautiful question, which we'll discuss when we get to, which is number 5, that says, for which values, right? For which values of x? For which values of x is f prime of x less than 0? This is actually what we have to worry about. Okay, Peter, Daito, I hope you're watching the program as we're trying to help you to understand how do you work with this particular question. It's a beautiful question. It's a graph. It's a graph question. It's the first one of applications of calculus, where you're going to take the concept of differentiation to try and use it, right, in drawing a graph. Now, I want you to pay attention to something very important. What we are going to be looking at is not everything calculus. Number 1, it has nothing to do with calculus. The solution to number 2 has nothing to do with calculus. The first time I'm going to start engaging calculus is when I get to number 3. Like I always say, you are not having problems with calculus. Your problems is algebra. Algebra gives you guys challenges. So I'm going to try and help you to understand how do you work with this cubic graph. It's not, if you know how to derive, you know exponent, coefficient, exponent minus 1, you understand how to find the derivative. You understand calculus. So the challenges you guys are facing are always about algebra. So I hope this will help you to be better at finding the solution. So let's start. Let's say fact, right? So the first question says to us, we need to use f of 2 equals to 0 to write down a factor. Now remember, according to the factor remainder theorem, if f of 2 gives you an answer of 0, it means that x minus 2 is a factor. This means when you substitute 2 everywhere where you see x, and you end up with an answer of 0, this 0 is what we know of as the remainder, right? So when I substitute 2 on my f of x, and I end up with an answer of 0, which means there's nothing remaining when I'm substituting 2 for x, right? Which means the factor that we are going to have here, right? Write down a factor. Our first factor is going to just be x minus 2. Why am I doing that? Well, because if you think about it, we were not substituting minus 2, we were substituting plus 2. So my x was replaced with 2. Now, if you take that 2 back to the left-hand side, or you subtract 2 on both sides, you end up with x minus 2 is equal to 0. This beautiful people that you see on the left is your factor. So don't confuse a factor with a root. That 2 is a root, but x minus 2 is a factor. So the answer to number 1 is x minus 2. That is our first factor according to this problem, right? Now, the next question says we need to find the coordinate of the x-intercept. Now, we are dealing with a cubic. A cubic will have 3 factors in total, right? We're going to have the first factor, we're going to have the second factor, and we're going to have the third factor. The examiner was very nice to you. They started telling you the first factor, which means we know that one of them is going to just be x minus 2. So what are we missing? We're missing the other 2 factors, because those 3 factors will simply give birth to the x-intercepts of this graph. You can't find the x-intercept if you don't factorize your cubic to its 3 factors. Now, this is where mathematics becomes exciting, because you've got many methods you can use. We discussed long division, we discussed monkeys eat apples plus bananas, we discussed synthetic method. So you take the technique that works for you, the one that you like, and then you use it to find the division that you're going to get an answer to. So I'm going to use monkeys eat apples plus bananas because I find it very exciting, right? I find it very, very exciting. So I'm going to say we need to divide this function, which is given to us as x cubed minus 4x squared minus 11x plus 30. I want to divide this by what? By the first factor we found, which was x minus 2, right? So how does this whole concept of monkeys eat apples plus bananas work? Remember, your cubic is in the form ax cubed plus bx squared plus cx plus d. So what you literally do is you divide the first guy with the first guy. This guy divided by that guy, right? So what is x cubed divided by x? That will give you x squared, right? And then, like I said before, there's a monkey hidden in the middle. There's an mx term there that is hidden in the middle, which we need to calculate. And then you go to the last one. You say, okay, we now know that x cubed divided by x is x squared. Now you go to the last term, which is your 30. 30 divided by negative 2 is going to give you minus 15, right? It's going to give you negative 15. We're going to have minus 15 there. And remember that x minus 2 has been there since the beginning of time. So we're going to drag it along and say that is basically our f of x, right? Now you're wondering, what is that m? What is that m? Well, you can use many methods. You can even use k method to find that m value. So I say monkeys eat apples plus bananas, right? What is a? A is a coefficient of the cube there, which in this case, you will notice on the far left that my a is actually equal to 1. So for a, I'm going to have 1. And the p-value, what is the p-value? The p-value is that 2 that we spoke about in the beginning. The 2 that we were substituting when we were looking for the first vector. That 2 is going to be my p-value, which I'm going to come back here and write as p, right? And the b term is minus 4. So I'm going to write minus 4 there. And this is 2 minus 4, which gives us a value of minus 2. Beautiful stuff. So which means my function of f of x is just as good as x squared minus 2x minus 15 into x minus 2. Now that quadratic you see in the first bracket will just give us the other two factors we're looking for of f of x, right? So this is not calculus. This is just your ability to factorize a cubic, which is using the factor remainder theorem or any other technique that you like. So this is going to be x times x, because that will give you x squared. Factors of 15 is simply 5 and 3. And then if you simply follow your algebraic skills, you know that the bigger one is going to follow the sign of the middle term. This one needs to be a plus, so we need minus 5 and plus 3 to get minus 2. So these are the factors of f of x. This is f of x factorized. Now, once we have this, we're then going to say for, of course, for the x-intercept, we're going to put f of x as 0, because on the x-axis, y is 0, and on the y-axis, x is 0. So I'm going to have x minus 5, I have x plus 3, and I have x minus 2. And then my x-intercepts are going to be, therefore the x-intercepts are going to be 5 is to 0. The other one is going to be minus 3 is to 0, right? Or the other one is going to be 2 is to 0. I believe you guys know how to use the zero factor law to find the solution to this. So 5 is to 0, minus 3 is to 0, and 2 is to 0. If you guys don't write them in point form, the examiner is going to be very upset and you lose marks because they asked for coordinates. Put it in point form. You always need to make sure that you are actually always expressing it in point form using coordinates. Very important, right? So let's go back to the next question. We know the x-intercepts of this graph. The next question is asking you for the stationary points. Now, this is where calculus takes over, right? The stationary point. The other word they use when they're asking you for the stationary point is turning points, right? They're asking for the turning points, okay? Now, what does a cubic graph look like? You guys need to know this. They're asking for the turning points. Stationary points and the turning point is exactly the same thing. Very important. Okay, cool. So a cubic graph looks as follows. It looks as follows, guys. It's got some form of this nature, right? It has got a turning point here. It's first turning point at the top, and it also has a second turning point here. So it's got 2 turning points in total, right? So we are asking you to find those 2 turning points, the coordinates of those 2 turning points. Now, I want you to understand, why is this referred to as the stationary point? Because on the left of the first dot, right? On the left of the first dot, right here, my graph is increasing. Very important for you to keep that in mind. The graph is going up because we are in South Africa, right? We do things from left to right. And actually, it is across the world of mathematics. We do things from left to right. So when I'm looking at this from left to right, moving in this direction, right? This graph starts by increasing, it's going up. When it gets to that point at the top, it's going to be stationary. It's not increasing. Think about it, guys. You're going to go up, right? You go up, 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 up. Before you come down, what must happen? You need to stop. And then do what after that? And then come down. And then as you go moving down, before you go up, what must you do? You must stop. And then do what? And then move back up. That's how a tennis ball behaves if you're just bouncing it, maybe, or you're throwing it up. It must go up, and then it gets to a certain point, it stops. That's the keyword, stops, which means it is stationary. It's not moving, right? And then it's going to come back down. So keep that in mind. And then if I look at my graph, when you're going down, then my graph is going to start decreasing, right? And then when it gets to this point, it's going to eventually stop again, or it's going to be stationary. That's another word they're using here. And then after that, it's going to start increasing again. Very important, right? So it's going to increase again after it. Now, what I'm going to do now is I'm going to keep the following in mind. The fact that they're asking for the x values where the graph is simply going to be stationary. So they want you to find the coordinates of the stationary point. So how do you find that? How do you find it? So you found it, or you find it by equating the derivative to 0. Remember, the derivative denotes the gradient. F prime of x implies the gradient, right? Implies the gradient. And any increasing part of a graph will have a positive gradient. But at the stationary points, the gradient will be 0 because it is actually a straight line. If you could draw a tangent here, it will have a gradient of 0 because it is actually parallel to the x-axis since y is not changing, right? So I'm going to find the gradient, and after finding the gradient, I'm going to equate it to 0, right? Gradient equated to 0 for me to find the derivative. So let's go back to the graph, right, and find the turning point. So for turning point, it's always the case. For stationary points or for turning points, what do we do? For stationary points, right, your derivative must be equated to 0. Beautiful stuff, right? So let's go and find the derivative first. So our function was given to us as f of x equals to x cubed, beautiful people, minus 4x squared minus 11x, and this was supposed to be added with 30. Now the first derivative is going to be coefficient times exponent, which is 3x squared, and then 2 times minus 4 is going to give us minus 8x, and then 1 times minus 11 is minus 11, and then the derivative of 30, which is a constant, will just simply become 0. You will notice that the degree of the function drops by 1 when you find in the derivative. 3 becomes exponent 2, 2 becomes exponent 1 on 11 becomes exponent 0 because that x to the 0 has disappeared. Now, after finding the derivative, if I was marking you, you have 1 now, right? The second mark you get when you take that 3x squared minus 8x minus 11 and equate it to 0. This is where I'm going to allocate the second mark for you. I'm rewarding you for knowing that at the turning point, or when you are at the stationary point, your gradient is 0. The derivative of the graph is 0 because the graph is not increasing or decreasing. It's got no change, no rate of change. Beautiful stuff. Okay, so from here, I'm then going to require you to apply your knowledge of math. If you can't solve from this, by the way, everything that I'm going to do is no longer calculus. Calculus only ended in the first line. This is the only line that is the calculus line. This is the only thing that is differential calculus. Everything I'm going to do from here, right, is no longer calculus. The derivative is the only part that is calculus. What I'm going to do as I move on is just your skills of algebra. So you guys are not really struggling with calculus. You've got problems with algebra and you need to go and iron those out. Beautiful stuff. For example, I need to solve for x. This is quadratic. What can I do? I can use the quadratic formula. If I don't want to use the quadratic formula, I can then factorize. 99% of the time, or in fact, most of the time, these turning points come out very funny. So I would encourage you, if you don't want to waste time, to go and use the quadratic formula to solve that quadratic equation. So let's take our chances on this because 11 minus 3 is actually 8. So this one is going to come out. So 3x and x factors of 11 are going to be 11 times 1. Of course, I need this one to be 11 and this one to be plus because the bigger product needs to follow the middle term. Because here, beautiful people, we're going to get minus 11x. And then from these ones, we're going to get plus 3x. And when you do minus 11x plus 3, you're going to get that minus 8 that you guys see there. So beautiful stuff right there. Absolutely exciting. All right, okay, cool. All right, so now, which means I can then say, therefore, my x is going to be 11 over 3, or my other x is going to be minus 1. Right, I found x's. The examiner is not interested in x's. They want the entire point, right? If I go back to my drawing, what do I know? I now know that at this point, what is the x value, right? I know what the x value is, but I don't know the corresponding y values. So I need to find the corresponding y values. Let's go back. Right, we know that the first turning point has got an x value. All right, let me just write them here to create space so that you guys won't struggle. Every time when you've got an x and you're looking for the corresponding y value, you just need to substitute that back to the original equation. Substitution, grade 8 concept, still part of algebra. No complications here. Very, very straightforward. So it means my first turning point, right, my first turning point has got an x value of 11 over 3. I don't know what the corresponding y value is, and that's what I still need to find. The second turning point has an x value of minus 1. Once more, I don't know what the corresponding y value is. So how do you find y when you've got x? Well, it's easy. Just go and substitute this x in the function. So I'm going to substitute for f of 11 over 3. I'm going to ask the graph. Don't substitute back to the derivative. You're going to get 0. If you take it back to the derivative, it's going to give you 0 because we got this answer when we equated the derivative as 0. You need to take these answers back to the original. You take them back to the original function of f of x, not the derivative. Please be careful of that. We see a lot of you guys making that mistake. So you're going to substitute that 11 over 3 cubed minus 4 into 11 over 3 squared minus 11 into 11 over 3 plus 30, right? And then you go to your machine, which I call the calculator. Remember, a calculator is an instrument and not a monument. You guys need to use it. Right, so which means my x is 11 over 3. So 11 over 3. Okay, cool. This needs to be cubed. Beautiful stuff. We need to subtract 4 into 11 over 3. Okay, great stuff. This has to be squared. And then you need to subtract 11, okay, into something very exciting, which we know of now as 11 over 3. Okay, great stuff. And if you close brackets and you remember to add 30 at the end, you press your equality sign, you end up with minus 400 over 27, which you can rewrite as minus 14.81. So minus 14.81 to two decimal places. So I'm going to write it as minus 14.81 minus 14.81. Okay, if you want to keep the whole number, you can still write it as a fraction form, minus 400 over 27, minus 400 over 27. Okay, minus 400 all over 27 is the corresponding y value. Right. I'm writing it as a decimal because if I need to draw, I need to know where is minus 14.81. It's easy to know that minus 14.81 is very close to minus 15, and it's very difficult to tell me where 400 over 27 is on the Cartesian plane. So be careful of that, right? So sometimes it's useful to write them as decimals because if you have to draw it, you're going to need to check on your Cartesian plane where the number is. I don't know where 400 over 27 is, but I know that 14.81, negative 14.81 is between negative 14 and negative 15 and very close to negative 15. Keep that in mind, very powerful. Okay, now we've got the first turning point complete. We need to find the second one. So we're asking for f of negative 1. Once more, you go back to your function. You do the same thing as what I did. You substitute negative 1 cubed minus 4 into negative 1 squared minus 11 into negative 1 plus 30. Do we need to show this Schofield? No, we don't. You can just go straight and work out the solution without showing the substitution, just finding us the answers. But you want to see the answer, right? So I'm going to be very naughty here. Okay, let me not be naughty. Let me be careful by rewriting everything in full and starting from scratch. Minus 1 cubed. We've got minus 4 into minus 1 with a square. We've got minus 11 into minus 1 close bracket, and the last one is addition by 30, and then if you press the equality sign, you end up with an answer of 36. So this is going to be 36 as the corresponding y value. That means the second turning point is minus 1 is to 36, which means we are now happy with what we have so far. We can start going to the next question. The next question, which is the exciting one, says to us here, we need to sketch f of x, right? It says sketch the graph of f of x. Okay, cool. That's the second last part of this question. So the drawing is not going to be complicated. We need to, of course, find a couple of things in order to draw. In fact, if you may allow me to just create a nice box here and help you to understand, in order to draw a graph, what do you need? A cubic graph. You need the x-intercepts, right, which we found. You need the y-intercepts, right, which we don't have. And you need the turning points. You might need the point of inflection, but it's not necessary. You can still manage to get a beautiful shape of how the graph is going to look without the point of inflection. But you should agree with me that we are not going to survive this without the coordinate of the y-intercept. Remember, for you to find the y-intercept, you are simply going to let x be 0. So I'm going to substitute x as 0 and try to work out what is the corresponding y value. And you don't even need to do that, because if you look at the function, you can tell what your graph is going to be. Because if you go back and you look at it, I'm expecting my y-intercept to be 30. There's the missing number. If all the x's become zeros here, the y-intercept is going to be 0 is to positive 30. So which means I already know where the graph is going to pass on the y-axis. If you had to calculate it using other techniques, you would need to do that. But it's important for you to understand that you can't draw the graph without that. So let's have our function. How does this look? Well, we've got the Cartesian plane, right? We've got the Cartesian plane. I'm going to have here my Cartesian plane without any complications. This is going to be my x-axis, and this is going to be my y-axis. Disclaimer, this is not going to be drawn to scale. Please be careful. Right. Okay, I've got them. Now what is going on? Now we need to plot the points that are important. We know that the graph is going to cut the x-axis at a couple of places. The first one that we found was 5, 2, and minus 3. So 5, 2, and minus 3. Those are the x-intercepts. One is 5, one is 2, one is minus 3. This is where it's passing on the x-axis. We know that the y-intercept is going to happen at 30, and we've got the coordinates at the turning point. We're looking at them. I'm just bringing them closer so that all the information we need can be in one place, and then you guys can be able to see what I'm doing. These are the x-intercepts. This is going to be where the graph is going to pass on the y-axis, and we've got our turning point here right below those two green boxes. Beautiful stuff. So now let's see, where is minus 3? Minus 3 is going to be, or negative 3 is going to be on the negative part of the x-axis. I'm starting with the x-intercept. So I'm going to say negative 3 is somewhere here, examiner. This is where I'm going to put my negative 3. And then where is 2 going to be? 2 is going to be on the right-hand side of the y-axis. So this is where 2 is going to be. And where is positive 5? Positive 5 is somewhere there. So I'm going to put 5 somewhere there. So I just represented my x-intercept on that Cartesian plane. It's not a Cartesian plane, it's a Cartesian plane after this Cartesian. Anyways, so the next one is the y-intercept. It's passing at 30. But before we get to that, let me just put the turning point. The turning point will always be between your x-intercept. So here's a tip. You guys know how to calculate sometimes. You get good answers, correct solutions in terms of the points where the graph is going to pass, but you struggle to draw it. So I want you to understand the following. Your turning points will always lie between the x-intercepts. So if I've got two x-intercepts here, one of the turning points is going to be between them. Right, two x-intercepts here and there, between them, somewhere either on top of the x-axis or below the x-axis. That's where my first turning point is going to lie. And then when I go to the other 2 points, between those x-intercepts, somewhere in the middle there, there's going to be another turning point either at the top or at the bottom. If the first turning point is at the top, the other one is going to definitely be at the bottom. Just as easy as that. All right, okay, let's go. Which means between 2 and negative 3, I'm expecting an x-intercept. And guess what? We're going to get a turning point at minus 1. I'm expecting a turning point at negative 1, between them. It's between negative 3 and 2. And this negative 1 apparently corresponds to 36 somewhere. Going to correspond to 36, so I'm going to write 36 here, right? And then the second one of the turning point is obviously going to be between 2 and 5. And that 11 over 3, if you don't know what 11 over 3 is, you can go to your calculator and do 11 divided by 3. You'll notice that this is actually 3.67. 3.67, that is 11 over 3. So 3.67, that's where the graph is going to also turn. So somewhere here, 3.67, here, 3.67, between 2 and 5. We're going to actually get the second turning point, somewhere closer to 2, right? We're going to get that particular point, which is 11 over 3. You can write it as a decimal, it's absolutely acceptable. So that is going to meet a negative value. Like I said, it's negative 14 point something. So that negative 14 point, we found it, 0.81 is going to be the corresponding y value of the turning point. This is the second turning point. That up there is the first turning point. Remember, our graph is going to cut the y-axis at exactly 30. So I'm going to draw this graph. It's going to be a curve, guys. Try as hard as you can to draw a beautiful curve that's going to look like this. It's going to get here. It's going to turn, come and cut through 2, turn at that point there and come cut through 5. And then go up like that. So this is the typical graph I'm expecting. What is happening here? Well, that is going to be 30. And this is how your graph of f of x would look if you had to write it or to draw it without any complications. Right. And the last part of this question was just asking something very, very powerful. They're saying for which values of x is the derivative less than 0? For which values of x is the derivative less than 0? Beautiful people, here they are asking you, where is the derivative less than 0? Let me go to the graph and do it graphically. I can do it algebraically, but I want to do it graphically for the benefit of you guys. They want to know for what x values, that's what the question is asking. For which x values, right? For which x values is f prime of x less than 0? Now let's write it in English. Let's express this in words, right? They want x, that's already in English. But what does this part mean? This part means the gradient. So they want x where the gradient of the graph is less than 0. Less than 0 means where the gradient is negative. All right. Now the gradient, like I told you, tells you in terms of the cubic graph where your graph is increasing, decreasing, or stationary. Right. So where the gradient is negative, beautiful people, if I combine those two words, gradient negative, if I add gradient and negative, what the examiner is asking for is where the graph, right, is decreasing. That's what they're asking. When they're asking you for the derivative, they're talking to you about the gradient of the graph. When they say less than 0, they're asking where it is negative. So gradient negative implies where the graph is decreasing. If they were saying gradient positive, then they will be asking where the graph is increasing. But because they're saying less than 0, they want where it is decreasing. So let's go back to it. I said we are in South Africa. We do things from left to right. So when you look at it from left to right, you start the graph by going up. It starts by increasing. So here, the derivative of the graph will be expected to be greater than 0 because the graph is increasing. But from the first turning point, which I'm going to now label as TP1, from TP1 all the way up to TP2, the graph is going down. The graph is decreasing, right? Because the graph is decreasing there, we are expecting the derivative of the graph to be less than 0. It's decreasing. And then after the second turning point, is you keep moving to the right, you will notice that the derivative will again start being greater than 0. So this will be another part where f prime of x will be greater than 0 because any tangent you draw on the graph at those parts will just simply give you a value of a positive answer because the graph is going up. Okay, cool. So now they're just asking you here in simple terms, find x values where the graph is decreasing. And you will agree with me that this graph started decreasing from x is 1, minus 1. From that x value of negative 1, that's where the graph started decreasing. It started decreasing from there. Let me use blue. From that point there, it decreased all the way. It kept on decreasing until the second turning point. So we're just asking all x values from turning point 1 to turning point 2, which you can rewrite like this. It's all x values, right? Let me use a white column between x of minus 1 and x of 11 over 3. Should we include? No, do not include. Including is a mistake because at the turning points, the graphs are not increasing nor decreasing. They are stationary. So the graphs are increasing and decreasing between the turning points. So in this case, please do not add the equal to part. It's just minus 1 less than x, which is also less than 11 over 3. So all x values between minus 1 and 11 over 3 are all the parts where f prime of x is less than 0, or in simple English terms, where the graph is decreasing. Beautiful question that I used to explain a lot in terms of graphs. I hope it has helped you and assisted you to understand how to work with cubic graphs.